Ja, tycker det är jag var en av de sista som gick över 3.
Glada minuter.
Hello. Is this on? Yeah. All right. So, if you come to this place and would like to know about Spring Boot, then you're in the correct location. If not, well, you're welcome to join the show anyway. So, my name is Mattias Severson. I work at a company called J-Way, which is a Swedish-based consultant company. And this is my Twitter handle, my email address, and also address to our company blog post where I write occasional blog. So this session will be about Spring Boot. We first start with a brief introduction of what it actually is. And next we see how you can start your own project using Spring Boot. We talk a little bit about microservices and how that applies to Spring Boot. And we spend some time looking into Spring Boot's production-ready features and what they provide, and a lot more on the way. Is there anyone here who has worked with Spring Boot before? Yeah, one? Well, you probably recognize some of this stuff, a lot of the stuff actually. Are there any Spring developers in the room? It seems to be the majority. You will have a great advantage because Spring Boot is based on top of the Spring framework, so you will recognize some of the stuff. And what current Spring versions are you on? 4.1 and 1? 4.0? Older versions? Okay. So Spring Boot is built on top of the latest version of Spring, so there'll be some news to you there as well, perhaps. So, what actually is Spring Boot? You may have played around with frameworks such as Drop Wizard or Sinatra, and Spring Boot were heavily inspired by them. This is a quote from the Spring Boot website, and it said that Spring Boot makes it easy to create standalone, production-grade Spring-based applications that you just can run. We take an opinionated view of the Spring platform and third-party libraries, so you can get started with minimum fuss. So, what does this mean? Well, if you take the keyword standalone in this context, it means that whenever you create a Spring Boot application, by default, you do not need any third-party dependencies. That is, you don't need an application server, you don't need anything else but a running Java environment. Everything else, by default, is baked into your application. For example, if you're creating a web app, you will find that you have the embedded Tomcat inside your application. So you don't need to deploy it to an external application server container. That said, you can still do that if that's the way you prefer to have your deployment. So, but it says also here that you take an opinionated view on how you should develop your application. Next keyword is production grade. We'll take a deeper look into that later. We have some features that are especially interesting for any DevOps guy that might be in the room, or your managers would like to see some data from your application how it behaves and so on. And application that you just can run. What does that mean? Well, since everything is baked into the Spring Boot application, when you create your product, all you need to do to launch it is create java-jar and then the name of your jar file. So it's very easy to get started once you have your jar file to launch your application. And We take an opinionated view of the Spring platform and third-party libraries. So by default, all the dependencies, transitive dependencies and so on, they are included. Of course, you can override that if you like. But as I mentioned before, you have, by default, the embedded Tomcat is used, but if you prefer to have an embedded Yeti server instead, you do some configuration and you run it on an embedded Yeti instead. And minimum fuss. As Spring developers, especially if you use older versions of Spring, you're used to these horrendous long XML files. Spring Boot preferred way of working is using Java-based configuration. But you will also learn that a lot of the configuration is already provided for you, so you don't have to declare all the beans that you're used to. All this plumbing, since it's already provided, that means that you can focus on creating your business logic rather than sort of gluing all the components together. So what about requirements for running a Spring Boot application? The Spring folk recommend that you use Java 8, and basically so do I, especially since Thomas mentioned in the keynote this morning that Java 7 will be end of life as of next month. By default, Spring Boot uses Java 7. But you can also use Java 6 if you do some configuration. You should be aware that there are some limitations with using Java 6. For example, you cannot use the latest servlet containers on Java 6 because basically they don't support it. So if you would like to use the servlet 3.1 spec with WebSockets, non-blocking IO and that stuff, you need to use Java 7. How long has it been around? It's a fairly new project. It was announced in September 2013. The first official release is about a year ago. The latest release was a couple of weeks ago. And the latest release is built on the very latest Spring version, so it's 4.1. Another thing about maturity when you choose a framework to build the application is the community support, and especially if it's an open source project, if you run into trouble, what can you do? And you will be happy to find out that the Spring Boot community is a very active community. The project leads answers questions at Stack Overflow. If you for some reason find an issue in the Spring Boot itself, you can file issues on GitHub, and they have very responsive issue management. There are some 130 contributors to the project so far. And last but not least, there's also a very well documented reference documentation on the project website. So you'll find many answers to your questions there. So, how do you start a new project? One way is going to this website, and we'll take a closer look at that. It looks something like this. On your left-hand side, you have your Maven coordinates. Basically, these are the project descriptions and so on. You can choose whether you would like to have a Maven or Gradle project. You can choose packaging, if it's a jar or WAR file. You can choose Java version. You can write an application using Java or Ruby. And you can choose which version of Spring Boot you would like to support. On the right-hand side is more project dependencies. So depending on the problem you're trying to solve, you may be interested in writing a web app. And that is what I will show you in a bit. There's also this other web support for example, if you prefer to use the XRS annotations instead of the Spring MVC annotations. Spring Mobile, you have the Spring Data project family that you see here. Template engines, database support, I/O, and so on. So if I choose to click this button, Generate Project, what will happen is that there will be a zip file downloaded for you, and if you unzip, that you can unzip and start the project work immediately. And this form is also available in the Spring Tools suite, which is the Eclipse clone, the Spring clone of Eclipse. So there's a similar form there for you, so you can start it within inside your IDE. And also it's available it will be available in the latest version of IntelliJ IDEA. So you don't even have to go to the website. You can all focus on working inside your IDE. So since I have done some preparations on beforehand, so I actually created this zip file and unzipped it and put it in my IDE. And first take a look. I choose a Maven project, so here's a POM file generated for me. Yeah, group ID, artifact ID, so nothing really that interesting. By default, Spring Boot, any Spring Boot project will inherit from the Spring Boot startup parent project. That will give you some Maven plugins and some reasonable defaults. That's at least for the first time you see it, you feel a bit uncomfortable. Why would I inherit project settings from someone else that I don't control? But I find it very usable, and I get a lot of support there. But if you're comfortable with this, you can use the dependency management tag instead, and use the Spring Boot starter dependencies, and that will cause Spring Boot to take care of any conflicts with regards to third-party dependencies. If you have one logging framework, it may be used in different versions or different third-party libraries, but Spring has already solved that for you, so you don't have to do any version conflicts anymore if you use Spring Boot. And that is also reflected here, because if you see the dependencies, there's only two dependencies. You have the Spring Boot starter web, because I choose to create a web project. And apart from that, there's only one other dependency, which is the test dependency. And the test dependency also contains stuff like Mockito and JUnit. And the starter web contains dependencies such as the embedded Tomcat. And I'll show you that in a bit, what's actually going on. And lastly, there's also one Spring Boot Maven plugin that is used for packaging. And I will show you that later on as well. So this is all there is in the POM file. It's really not much considering this is a running web application. And you did not have to write a single line of code to get it, so that's really good news. Take a closer look. Here you see that we have a start class. And if you just click on that, we see our typical Java main method. And that implies that you can actually run this project as any normal Java project. Moreover, if you start to debug, you can point it to this, and that is very handy if you run into trouble trying to solve that. So the main method, all it does is called a Spring application, and the run method of it, and that is basically we start Spring, create application context for you, start wiring and stuff like that. And we need to provide it with a reference to which application is actually started. And in this case, it's a reference back to the very same class. And there's this annotation here that is kind of magic, and I'll spend some time later on to explain that. So this is our main class. And if I go ahead and create controller, so we can see that we actually have a web project. This is a REST controller that was introduced in Spring 4. I do request mapping, and being lazy, I just do it in the root. And that's my typical controller. Nothing really fancy, but you can imagine this was the important business logic that you're trying to solve. So, does this actually work? Well, let's see. We use Maven and we create a package of it. And wait a few seconds, and builds fairly quickly since, well, there's not much there. And if I try to execute this project, you can see that there's a nice ASCII art logo telling you that Spring Boot is starting. And you will also see that it starts fairly quickly, given that it's actually a servlet container that is running. And to prove that it's actually working, we better check. And voila. So compared to what you normally do when you create a web project, all I had to do to have a web server up and running is download a zip file and write 5 lines of code in my controller. So there's a very rapid process deciding that I would like to start a project until I actually have something up and running. And that is one really strong selling point of Spring Boot. So, but it seems kind of magic. How can that work? What do we actually get? If we take a closer look at the jar file, that will reveal some of the secrets. And as you can see, there's quite a few files here. Importantly, these are the 2 Java files that I show you in the project. My example controller and sort of the main class. You have the manifest that is used by Maven and the jar file. And here in the lib folder, you can see that Spring Boot packages all the third-party dependencies that are needed. And these are transitive dependencies pulled in by the Spring Boot Starter Web project. And first of all, you see the Spring Boot dependencies. I have some logging dependencies because you may have noticed when I started the project we had some nice printouts. Here's the embedded Tomcat for you. Hibernate validation for input validation of your web servlets. We also have the Spring dependencies. And then there are some helper classes, because normally if you package jar files inside a jar file, Java won't care. So, but here's a boost loader provided with Spring Boot that actually goes out and reads those jar files and put them on the class path. Right. So that gives you some idea what's going on, and let's head back to presentation. So by now, I've said starter prompts several times. And if you remember the initial web page, you can see all these frameworks that were denoted with checkboxes. Basically, every checkbox you tick corresponds to one dependency in your Maven file. And different dependencies have different solve different problems. For example, we saw the Spring Starter Web that created an embedded Tomcat for us. If you don't like Tomcat, well, you can use embedded Yeti instead. And there's also, as of the latest release, there's also the undertaken servlet container, which is provided from JBoss as part of the Butterfly application server. And I have not checked the figures, but it's supposed to have a smaller footprint and less memory requirements. More often than not, you need to secure your application, so for this reason there's a starter prompt for the Spring Security project. You will find starter prompts for the Spring Data families, such as Mongo, JPA, Gemfire, REST, and so on. Starter prompts for WebSockets. If you need social media interaction, there's starter prompts for the Spring Social projects, such as Facebook, LinkedIn, Twitter. Starter prompts for Spring Batch, Spring Integration, and many others. All in all, there are some 40 different starter prompts. So the starter prompt, what it does, it's actually put the dependencies on your class path, because and nothing more. So how does Spring Boot actually, just putting dependency in a class path does not create Spring Beans, right? So there is some magic to this. Remember that I showed you the Spring Boot application annotation in the main class? That is actually an annotation that is composed of 3 different other annotations. And those of you that have used Java-based configuration in sort of normal Spring, standard Spring, will recognize that it's composed of a configuration annotation. And that is basically telling that any class annotated with this annotation will act as a Java-based configuration, and there may be the bean annotations that create Spring Beans for you. It's composed of a component scan annotation, and that will scan from the class that's been annotated in this, our main class. It will scan recursively in all subdirectories from that point to pick up any other Spring Beans that you may have in your projects, such as services, repositories, controllers, and so on. And the last annotation is the enable auto configuration. And now we're getting into really the core of how Spring Boot works. It's probably a little bit more, the next slide is probably a little bit more than you actually will use in your code, but nevertheless I find it beneficial so you get an idea how stuff works behind the scenes. So the enable auto configuration, that is what actually allows Spring Boot to guess what are required. And it does so by, first of all, checking on the class path. So internally, Spring Boot uses this conditional class, goes ahead, reads the class path, that is jar files in your lib folder, to see whether or not a specific class is present. If it's not present, well, obviously it cannot create any Spring Bean from it. If it's there, then it can go ahead and create a Spring Bean. Some beans depend on other beans, so for this reason, if the first bean has been created, you may also would like to have dependent beans, so there's the conditional on bean annotation that is used to solve the dependency problems. And most importantly, Spring Boot will actually back off. If you choose to create your own bean configuration, Spring Boot will not create a bean of the same type, because it assumes that you know what you're doing, and if you're not happy with what Spring Boot provides, it will back off and tell you, I trust what you're doing, so I go with your way. So this is how it allows you can write a Spring Boot application like you would do any ordinary Spring application and do all the configuration yourself, because Spring Boot will not create any bean whatsoever, provided of course that all beans are there. And it is handled with the conditional missing bean. So this is kind of how it works behind the scenes. And I've done a couple of Spring Boot projects, and I have not used these annotations myself. There may be times when you need to use them. Well, now you know they're there, and they're there for a good reason. Microservices. There seem to be as many definitions of microservices as there are developers. Some least common denominators include that it's an architectural style in which you separate services into separate applications. And, well, is that good? But no one really talks about sizes. And that's probably for a good reason, because it depends. As we saw in this very example, is usually there's little own code required. That means that you're very concise and probably trying to solve. And you also saw when we looked in the zip file, I had only written two Java files in my project, but there were lots of other third-party dependencies. So that's why I put own within parentheses. That said, how big is a Spring Boot application? The application I showed you just then, I think it's ends up around 12 to 13 megabytes, including the embedded Tomcat container. So it's fairly small. And memory requirements is some 300, I don't know, 20 to 30 megabytes or so, also included in embedded server container. And this is small enough to fit in an Amazon micro instance, for example, if you're doing cloud development with AWS. You can make this even smaller. As stated earlier, if you use undertow instead of Tomcat, it will be smaller. And not all projects you're trying to solve involves a web server. There may be a batch job, for example, or something else, and then all the Tomcat dependencies disappear. But that said, I mean, there's nothing prevents you from writing big monolithic application with Spring Boot as well. But it is sort of, microservice is a really good buzzword nowadays when you're trying to introduce a framework to a community. So, that's why the Spring folks are using this word. So continuing to production-ready features. This is where it's more the DevOps part of this presentation. And there's a famous quote by Michael T. Nygaard in the book Release It. And it says, feature complete is not the same as production-ready. And why? What does it mean? Well, usually you have all these use cases you're trying to solve, and then when you go to production, there's all this non-functional requirement that you kind of heard before, but sort of neglected until the very last minute. But Spring Boot actually provide this for you, because they have acknowledged that it is a very common problem that people are trying to solve. So why should I try to solve the same problem in every project that put in a dependency or sort of copy-paste whatever I need? So there's this Spring Boot actuator that solves this problem. It provides metrics, health checks, environment trace, and yeah, more things. So take a closer look at how we can use that in our project. So it turns out that the actuator is just another starter dependency. So you can also, and while we're at it, we can see that all the Spring Boot starter, they have the same naming convention, so they all start with Spring Boot's starter, so it's make it easy to have completion within UID. And we can omit the version number since we inherit that from our parent project. And if I this time choose to start the main method and restart my project, first of all, we make sure that this application still works, so that's good. But what happened now is that we enabled a range of new endpoints that we can use. For example, if you have a high availability system, you may have two instances of your application up and running, and you have a load balancer in front of them. And with this setup, the load balancer needs some way of knowing if an instance is healthy or not. So for this reason, we have the health check that provides status up in this case. And it's a bit more clever than you would just think when looking at this, because if you have a data source on your class path, Spring Boot will actually call the data source to make sure that the database is running as well. Same thing if you have a Mongo instance or Redis cluster, and it will make sure that not only your application works, but the underlying infrastructure is also up and running. And of course, if it's not, you will have a status down and you will have an HTTP status error code instead. There's also a trace endpoint in which you will see the last request that came in. For example, you can see here that we call the get on the root. You can see all the request headers, and you can see the response. And this can be very useful when you try to debug why a particular request did not work as expected. There is the metrics endpoint that will provide you different kind of metrics. For example, you will see the Java memory here. You will see the heap size. You will see how many classes that were loaded. You will see the GC. But there's also different metrics for how many times your endpoint has been requested. So for example, since I requested a health point yesterday, you can see that it's, on this line you can see that it's been requested once. This is the one here. You can see the requested a health endpoint, and you can see the response status code was 200, which is okay. I have requested the roots resource, that is this one here. And if we make an additional request and reload the metrics endpoint, you will see that now the root has been requested 4 times with 200 response. If there would be an error, it will be reflected here as well. So if I call a bogus endpoint, it does not show. And here you can see that's the default error page that of course you can customize. Status code is 404, and if I return to the metrics, we see that we now have a 404 being recorded here, and you will see 500 status, all the status here. Those are the counters, the basic count up or down. There's also Gorge metrics, and they will tell you the response time of the latest request of each endpoint. So you can see the route here. Since it does not do very much, it's fairly quick, it only took 1 millisecond. The health endpoint took 31 milliseconds. So this can be very useful if you try over time to check either the traffic to your website or the overall performance of your system. I'll show you one more endpoint. This is the environment. That is what actually is used now. So here you can see system properties. I have the latest version of Java installed, for example. All other system properties that you may have. Here are my environment properties. I have the Java home directory and so on. So this is also very helpful to see what's actually going on. If there's a specific environment variable that may point in the wrong direction, there's an easy way to access them just here. But there's a problem with this. This can be very sensitive information, right? Currently, as it stands now, it's exposed not only to me as a developer or a DevOps person, it's exposed to the entire internet because it runs on the same port as my application does. So there can be a security vulnerability because it allows basically anyone to see my current environment. Anyone can do health checks and so on, and for good reasons they might not like that. One way you can solve this is using Spring Security, and by just adding the Spring Security starter form that will have basic authentication for all these endpoints. Another way of solving this is that you can just add another property, and if I restart the application, I change the port of this actuator. So before it was 8080 like the application, but now I change it to 8090. And if I try to reload it, you will see that I can no longer access my environment on port 8080. But, of course, if I change it, it's on 8090. And here you can also see that now, as part of the environment is this property that I just changed. So it will also be listed here in the environment page. So there's more features to this actuator. If you would like to create your own metrics, you can do that. That's an interface to implement. If you would like them exposed as a RESTful endpoint, you can disable that. And you can tailor the names of these endpoints. You can also choose if you to access this data using JMX or even SSH. So, and yet again, all I did was add another dependency, and this data is provided for you. And then you tailor it and customize it according to your need or your organization. If you like this sort of fancy dashboards where you have all the performance metrics and so on, you will be interested in knowing that you can export these metrics to drop wizard metrics, and then you can just attach a graphite server on that, and then it will be visualized for you. So, what else? Briefly mention some of the other features for you. Logging is enabled by default. It uses logback, but if you're not happy with that, you can use log4j as left4j and YAML logging instead. Log rotation is enabled by default, so you don't run out of disk space. There's a nice predefined format for logging outputs that makes it more easy to parse. And you can change the name and location of the file name, of course. Many properties in Spring Boot are highly configurable. There's a whole range of things you can change. I already mentioned the management port for the actuator. You can change the server port for the applications as well. Timeout settings, security settings, gzip compression, and if there's a specific setting that you're interested in, go to the Spring Boot reference docs and see that if it's there. Chances are it's very likely that you can just by adding another line. The configuration can also be externalized, so you don't have to bake it in your application, of course. You can override it using command line arguments when you start the application. You can use external properties files. You can use Spring profiles. And there's also support for YAML if you don't like the properties file. Command line runner is, if you don't have a web server, you may just do a one-off shop. And you would like to parse input arguments yourself, then there's an interface for that. Related to that, there's also the exit code generator that gives you a nice exit code once your application shuts down. If there's an exception, well, you may have a specific number for that. There's a wide range of application events and listeners that you can use. For example, there's also auditing that can be enabled to check what your users do, which interfaces they call, and so on. And there's a specific repository for that. You can use the message channel integration for the metrics, for example. If you just add another dependency, you can have a metrics channel that all events that are published to the metrics endpoint as part of Activate will also be published to a metrics channel, so you can subscribe to that. Database schema migration, support for Flyway and Liquidbase. And yeah, lots of other features. If you do server-side view rendering, there's a handful of different template engines that are supported. FreeMarker, Groove templates, FineLeaf, Velocity, and Mustache. If you're still using JSP, you will find that you may have trouble with that, but that is not part of the Spring Boot, that's part of the embedded servlet container. It is possible to create a JSP application with Spring Boot, but then you need to use Tomcat, and your file or your project needs to create an executable WAR file. So that's a limitation. That said, you can use Spring Boot to create an ordinary WAR file without the embedded servlet container, and you can deploy it to any WebSphere or Glassfish or what have you. If you're interested in knowing more, here are some links that you may find useful. The Spring Initializer, I already showed you how you create your project. The second link is also very useful. It's a Spring Guides page. And on this page you will find more than 70 different projects that shows you how you can easily get started solving different problems. It can be how you start creating a web server, it can be how you start using JMS, how you create a project using AngularJS, how you create a Mongo database, and so on. And the step-by-step instructions, very easy to get followed, very simple example. And so if this particular problem you have, start on that page to get an idea how it works, and then you can dig further into your solution. And for this reason, there's also the reference guide I mentioned earlier. It's very comprehensive. So there's also a good source of knowledge if you get stuck. And of course, Spring Boot is built on top of Spring, so chances are that the problem you're trying to solve is related to Spring, and then you'll have all the Spring knowledge base as well that you can look into. So basically that was my presentation. These are my coordinates once again. Does anyone have any question or would like to know more? Either you can just ask now or you just find me during the day and the rest of the conference. No one? All right. Thank you very much for your attention.